So this video I'll be explaining the electronegativity trend for period 3 for A-level students, JC1 specifically, or if you are a student from other countries not in Singapore taking this A-level examination, feel free to use this video. Okay, so electronegativity trend is basically like electronegativity, and then this will be your elements. So you always start out with sodium, magnesium. After many rounds of writing, you're gonna memorize this. Okay, I can promise you're gonna memorize. If you repeatedly revise this chapter, you're gonna memorize this pattern. Sorry, in less than, I'll say less than 1 month. Okay, that's quite long. Okay, then you have P, S, chlorine, and argon. Okay, electronegativity of argon, do we usually draw it? We don't. Okay, what is electronegativity? It basically is the ability for an atom, keyword is atom, because electronegativity is only found in what? Covalent bonds. Okay, covalent bonds. It's the ability for an atom, which is these atoms. We still call them atoms. If they are in covalent bonds, we still call them atoms. Unless they are ionic bonds, then we call them ions. Okay, we still call them atoms. Okay, the ability for this atom, for example, for this atom, there's a shared pair of electrons here, right? There are two electrons here. Okay, ability for this atom, the nucleus here, to actually pull this shared pair of electrons towards itself. So for example, over here, right, if I got a lot of, for example, I got 4p plus, here I got 3p plus, which one do you think will pull the electrons a bit more? Remember, p plus and electrons, they will form electrostatic force of attraction because they are opposite charge. Anything with opposite charge will form electrostatic force of attraction. So in other words, 3p actually has more stronger force of attraction than 4p has more stronger force of attraction than 3p. So in other words, this part will actually attract it closer. So in other words, it will basically what I say is it will polarize the electron shell. It polarize the electron cloud. Okay, so what happens is that it will look like that. Let me try drawing. Okay, maybe this is 3p. I'll just write the number of protons. Okay, 4p plus. What happens is that the two electrons are much closer here. So in other words, here actually experiences what? Partial negative charge and partial positive charge. Why so? Why do you tell me this is negative? You saw me may see 3p plus 3p plus 4p plus Why is it that two electrons go over, it become positive? It become negative, partial negative. Partial negative means it's a half charge. In other words, it's not like a full proton or electron charge. It's a half charge. Okay. Reason I say is this is because over here, for example, I have 3p, right? These are atoms. What are the atoms? Atoms are electrically neutral, right? So in other words, I have 1, 2, 3. Maybe not. Okay. This is just an example. Okay. 3 electrons over here. Over here, I have 1, 2, 3. Where's my fourth electron? It's paired here. It's paired over here. Where's my third electron for this? It's over here. It's in the middle. Okay. What happens is that here, again, I have 1, 2, 1, 2, 3, right? But now instead I have 4 protons, but 1, 2, 3, 4. I have 4 electrons plus 1 more electron. Where this electron come from? This electron come from the shared pair from here. It comes from here one. Okay, so it's actually this become positive because it has 3p plus and 2 negative electrons. These are electrons. So in other words, 3p plus minus 2 electrons will give you what? Positive 1 more, because you have 1 more positive 1. It's kind of like units, 1 more unit of positivity. This has 1 less unit of positivity because why? 1, 2, 3, 4, 5, but only 4 protons. That's why it's partial negative, but it's not a full charge. Okay, so essentially electronegativity, as you guessed it, it will what? It will actually increase. Okay, because in the ability to attract a shared pair of electrons. Keyword is shared pair of electrons between a covalent bond or within a covalent bond. Okay, so in other words, from here to here, I'm pretty sure everybody knows what I'm going to say next. Proton number increase, so therefore its nuclear charge will increase from sodium to chlorine. Okay, it will increase, and when it increases, what happens is that successive electrons, again we talk about successive electrons because we talk about atoms only. Okay, successive electrons are added to same, keyword is same, outermost electron shell. So what? So the shielding effect remains the same, right? So again, effective nuclear charge is defined by this. Okay, effective nuclear charge equals to nuclear charge minus shielding effect. So essentially, if my shielding effect remains the same, same, but this actually increases. So effective nuclear charge will actually increase overall. Overall will have an increase. Okay, because effective nuclear charge is just nuclear charge minus shielding. Okay, this effective nuclear charge. So essentially now effective nuclear charge increase, so there's a stronger attraction, right? So between the nucleus and the valence electron, there's much stronger attraction. You see this arrow, red arrow, I'm drawing over it. It has much stronger attraction. So in other words, if I have another atom here, right, this is an atom. In other words, it will have a stronger attraction to this. So stronger attraction means what? It will pull over. For example, I have a magnet. I have a magnet here. This is magnet and this is magnet. This is a metal. Okay. If this is stronger, this is stronger. Strong, this is weaker. Okay. The metal will come over here one, right? So it's the same reason or same logic. Anything that's stronger has more charge, has more protons, is more stronger, more effective nuclear charge. It will shift towards that side. Okay. So if it shifts towards this side, it means what? It means that the electronegativity, which is a value given to atoms, will increase. So electronegativity will increase. That's why you have this point here. Okay. Generally, you can just draw a straight line across. Okay. But it's definitely not the actual straight line. Maybe just do it like that. Maybe I'll just advise you to draw freehand, because in actual fact, this is not it's not exactly a very straight line. Okay. But it's just maybe like a slight curve like that. So you can't really see the difference. Okay. But usually we draw straight lines. So if you're very scared the teacher's gonna mark you down because it's not a perfectly straight line, just use a free hand to draw. But just make sure it's straight, something like that. Okay. Yeah. Then that's all for electronegativity.